Hey everybody, today I'm demoing PViz. It's a codebase analyzer that turns a repository into a structured dependency bundle, so LLM assessments about the codebase are faster, more consistent, and easier to verify. PViz analyzes a repository and produces a structural JSON representation of files, modules, and their relationships rather than just relying on raw source code. Because the output is structural, its usefulness can carry forward across multiple iterations as long as the overall structure of the code base remains consistent. That lets you reuse the same artifact for follow-up LLM assessments even as implementations change. There are diminishing returns, obviously. Major refactors eventually require reanalysis, but for incremental changes, this provides strong, reusable grounding. I'm going to do a quick run through of the platform. So obviously, login. PViz uses standard authentication with email verification, so access is tied to a verified account. This is this dashboard. It shows token balance and recent jobs, although the design is in flux and there's a lot of space to add additional functionality and oversight. PViz is token metered, so usage is predictable. Tokens are consumed per analysis based on the repository size and configured depth. This makes it safe to run on large repos without surprise costs. The pricing is not set, so take this for what it is, but it kind of gives you a general idea of what the plan is. Jobs are the core workflow. You pick a repository, you run the estimation, you run the analysis, and then you review the outputs. It's very straightforward. So for this demo, I was going to pick a random repository, but I think this, just to ensure that I'm showcasing the full functionality, I'm going to choose BAI. It's split pretty evenly between Python and TypeScript. The program currently can parse Python, TypeScript, JavaScript, and the intent is to add additional languages. But in order to start a job, you just copy over the URL for the repository. You start this, or you paste in the repository address. I've also added a AI wrapper that allows you to submit some high-level questions if you just want to jump right to it instead of receiving the output and doing that on your own. So for this demo, we're just going to add some simple questions. Let's see, what are the main runtime components, modules, and how do they interact end to end? All right, so we'll use this question parsed. So we're going to estimate the cost based on the files and the source code. That's the cost. Like I said, the pricing and the metrics are still in flux, but for the purpose of this, let's go ahead and start it. It goes to the job page, and it gives you an ongoing status, lets you know when it's done. It's relatively quick. Obviously, it takes longer the higher you get in code base size, but for smallish repositories, 15-30 seconds. Been able to do a million lines of code repository. Took 4 or 5 minutes, so it really just depends, and it's obviously still under development. But once it's done, you get a download result option, and it takes you to this, which is the JSON output. So what we're going to do is copy this over into the notepad, save it as test2. All right, and what you can do, you just go to where it's saved, add it, and we're going to type in that same question. So while that's going, I'm going to go to my email, and you get emailed the JSON information. This is on a time, has an expiration time. So if this doesn't work, you'd have to go back into the platform to download the link. But this gets emailed to you, and then you also get a follow-up report for the response. I'm not going to read through it, but I'll go through it slow so you can kind of pause and look at the response. But going back to this, if you wanted to do it on your end, you could just feed in the same question with the artifact, ask the same question, it gives you a very similar response. This is not raw source code. It's a normalized representation of the repository, but the JSON is the single source of truth for the analysis and for context generation in the LLM. It's what the email response is based on and what any follow-up LLM assessments use as their grounding context. It's also important to note that response content and quality can vary depending on the LLM being used, even when the underlying JSON is the same. At the moment, the platform uses Gemini Flash 2.5. One of the practical advantages here is its large context window, which allows mid to large size structured JSON inputs to be handled in a single pass without splitting and chunking. But that is still additional models will probably be added. But if not, you're also able to take the JSON on your own and feed in the questions on your end. So just for follow-up, to show that additional follow-up questions can be done, we're going to do just a basic question. Where would I add logging and telemetry to trace requests? To summarize, PViz converts a repository into a reusable structured JSON artifact. That artifact grounds LLM responses, supports follow-up assessments, and gives you consistent answers without reprompting or re-ingesting code. For each job, we retain only the generated JSON for recall and follow-up assessments. The original code base and any intermediate or background artifacts are not stored internally once analysis completes. Feedback is going to directly shape the next iterations of this, including analysis depth, supported patterns, languages, model options. But if you're interested in trying it out, feel free to reach out to me. But yeah, just real quick, we can go through the response, the structural assessment response based on just that single JSON for the entire code base. Obviously not going to read through, but you can pause and read the response. But yeah, thanks for giving me 10 minutes of your time, and hopefully someone out there is interested in this.